Okay. Hi everyone. So today, let's do this question together called the odd even linked list. So this is from the main LeetCode daily challenge. So I think so. I just read the description of the question. I think it's already pretty clear. So for the odd and even here, it's not referring to the value of the nodes. Actually, it's referring to the index number. It said node number and not the value in the node. So basically, it's asking you to connect all the nodes on the odd place in one linked list, and then we connect all the nodes on the even place into a new one, and then we concatenate them together. So the purpose, the goal of this question is already pretty clear. So here we have we might have several ideas to do this. So my initial idea will be we start from two places. We start from the first place, which is the first odd node here, and then we start from the second place, which is the first even node here, and then we start working on. So basically, the requirement saying that we need to run in O1 space complexity, which means we need to do it in place, and then O nodes time complexity, which means we cannot do any nasty for loop, but we can definitely do it in two paths. So the first pass, we concatenate all the nodes on odd place, and then in our second round, we concatenate all the nodes on the even place, and then we concatenate then we link the end of the first node and then the head of the second node together, then we get our result. So in this case, in our first one, we connect 1, 3, and 5, and then we memorize the last node, which is 5 in our first linked list, and then we do 2 and 4, and then we memorize the head of our second, the even linked list, and then we link the last node of our first linked list and then the head of the second linked list together, and then we have 1, 3, 5, and then 2, 4. So this is my initial thought. So in this question, so to implement that, we need two dummy nodes. Actually, they're not like dummy nodes; they're like two trackers to help us to accomplish the task. So the first one, as I said, we need to start from two places, first one and second one. So let's name our head off, and then we also need an even. So even will point to the second node at the beginning. Okay, so now we have this. So now we need to figure out how we're gonna concatenate all the odd node and the even node. So here, uh, we need a while loop here. Actually, I think we can combine the two paths into one path because we already have these two variables and they're actually moving at the same time. For example, 1 move to 3, then 2 definitely need to move to 4. So let's figure out what we put here in the while condition. So let's start from 1. So 1 is our initial odd node, and then I will move to 3 and then 5. So we want to stop at 5. So the condition of it to stop at 5 is either the next odd next is null, or odd next is all. So for odd next is all, for that case means if we don't have the node 5, we only have 1, 2, 3, 4, then we want to stop at 3, right? And the next is null in that case. So here for the while loop, we want odd next and odd next. So only with this condition we can make sure the odd node will stop at the last odd node we want. It will never be a null node. The reason that we can't get a null is because our next step of this is concatenate the last node of the alt list with the head node of the even list. So if this one is null, then we cannot do our next step. So this is our stop condition. So here, inside the while loop, it's pretty trivial. So we need to connect our alt node with the next node of the even node, because we know that the alt and even will move together. So we can do this. And then since we already moved the next pointer to this one, then we can simply do this to move the alt pointer, and then we do the same thing on the even pointer. Now my alt is already on the new place, so I can definitely do this. And then I update the even pointer. All right. So now I have everything here, and then we need to do our last step, which is concatenate two together. So here, since my even pointer already moved, so I need another variable here to memorize the head of my even linked list. So let's call it head2, which is equal to even in this case. All right, now we have everything we need. We know that now my alt pointer is what we want here, and we need to connect this one with my head2. So this is what we want, and then we return head, because we didn't move head at all. So now run the code. Okay, made one mistake here. So maybe it should be good. All right, have the correct value here. Let's try another test case, the second one. Look good to me. Let's try another one. Let's try a different case, which is we have 1, 2, 3, 4. Yeah, seems like everything's good. Here we also need to handle one edge case here, since we have even so the even is pointing to head next. What if the head is the only pointer, or we don't even have head? So if we don't have head, then we directly return null pointer here, since they want us to return pointer. So I'll return null pointer here. Okay. All right. So this is the process of how I do this question. So I start record the video from scratch. I haven't done this question before, and I also didn't do this question before I record the video. So I just want to show guys the process of how you think a algorithm question when I first give to you and you never meet with this. So all right, thank you guys.